Good evening, children. Good evening to all of you. Welcome back to the mathematics class once again. I think this is the last class in this series, okay? So in the afternoon session, just I have discussed about the inverse trigonometry functions, the domain and range, okay? The principal value branch of each inverse trigonometry functions. Now I am going to discuss some problems, especially which are asked in the board examination, the recent past years, okay? And after that, I will be doing some problems from differential equation also. Only some problems from the chapter differential equation. So that's my planning today. Okay, welcome back once again. I think my audio voice is coming to you. Okay, let's start. Okay, so let me take this question. Inverse trigonometric functions. Simplify tan inverse cos x upon 1 minus sin x. Okay, tan inverse of cos x by 1 minus sin x. So what we have to do is, inside this bracket, cos x by 1 minus sin x is there. So that we have to simplify and express in terms of tan. Okay, and after that, we may be able to apply this simple basic property of inverse trigonometry function, that is tan inverse tan x equal to x. So we have to express the term inside the bracket, simplify and express as into the form of tan. Okay, tan something. So let's do that. What to do, how to do actually. So consider cos x by 1 minus sin x. Cos x by 1 minus sin x. So I will write this cos x as sin pi by 2 minus x. Sin pi by 2 minus x divided by 1 minus. In the denominator, sin x is there. Sin x, I will write cos pi by 2 minus x. Now this numerator, let us take it as this pi by 2 minus x. For the time being, I will substitute as some y. Okay, pi by 2 minus x, I will take it as some y. Later we will replace it. Then this is equal to the sin y can be written as 2 sin y by 2 cos y by 2. Sin 2 theta is 2 sin theta cos theta. Yeah, sin 2x is 2 sin cos x. That formula, okay, that identity. And divided by 1 minus cos y. What is 1 minus cos y? 1 minus cos y is 2 sin square y. 2 sin square y by 2. 1 minus cos y is 2 sin square y by 2. All these are the basic trigonometric identities. So what happens then? This is equal to 2 cancels. Sin y by 2 also cancels. Then remaining is cos y by 2 by sin y by 2, and that's equal to cot y by 2. Okay. Cot of y by 2. And this is, again, we will write as tan of pi by 2 minus y by 2. Okay, cot theta is tan pi by 2 minus theta. Okay, so cot y by 2 is tan pi by 2 minus y by 2. So we have simplified and we have got this in terms of tan. Okay, therefore the required expression, the given question becomes tan inverse cos x by 1 minus sin x actually. Tan inverse cos x by 1 minus sin x, that is equal to tan inverse tan pi by 2 minus y by 2. Tan inverse of tan pi by 2 minus y by 2. Then that is equal to tan inverse of tan x form. Tan inverse of tan x equal to x only. So tan inverse tan pi by 2 minus y by 2 means that is pi by 2 minus y by 2. Now we have to replace our y, okay? The y is only a temporary substitution, so we have to replace it. So what is y? What we have taken as y? Y is equal to pi by 2 minus x, okay? Y is pi by 2 minus x. So replace it. Y is pi by 2 minus x, isn't it? So pi by 2 minus of pi by 2 minus x divided by 2. That is equal to pi by 2 minus pi by 4 plus x by 2. Isn't it? So that is again reduces to pi by 4 minus, pi by 2 minus pi by 4. That is equal to pi by 4. 90 minus 45 is 45. Okay. So pi by 2 minus pi by 4 is pi by 4 plus x by 2. Okay. So this is our final answer. The next question. This is a very direct question actually, very simple. Evaluate sine inverse of sine 3 pi by 4 plus cos inverse of cos 3 pi by 4 plus tan inverse 1. Simply we can evaluate each values and substitute it. So what is sine inverse sine 3 pi by 4? So first we have to see, we know the property sine inverse of sine x is equal to x. Sine inverse of sine x equal to x. But that is only true when x is in that particular principal value branch. Principal value branch of sine x is what? Minus pi by 2 to plus pi by 2. Then only we can apply this property directly. Sine inverse of sine x equal to x. But here you see 3 pi by 4. 3 pi by 4 is not belongs to that principal value branch of sine inverse. Okay, 3 pi by 4 means actually in degrees that is 135 degree. Very clearly that is not belongs to the principal value branch of sine inverse. So we have to convert that angle, that value into the some value which is in between minus pi by 2 and plus pi by 2. Okay, don't directly write sine inverse sine 3 pi by 4 is 3 pi by 4. That is wrong, because 3 pi by 4 is not in the principal value branch of sine inverse function, isn't it? Okay, so first you take the sine 3 pi by 4 only. So sine 3 pi by 4 we have to convert. Okay, that is, how can we convert it? Using trigonometry. This is same as pi minus pi by 4. Okay, 3 pi by 4 is same as pi minus pi by 4. So sine 180 minus theta. Sine pi minus theta is what? That is sine theta. Second quadrant sine is positive. Okay, pi minus pi by 4. Second quadrant. So sine is positive only. So sine pi by 4. So therefore sine inverse sine 3 pi by 4. Sine 3 pi by 4 becomes sine inverse sine pi by 4. Isn't it? And you know that pi by 4 belongs to the principal value branch of sine inverse. No, pi by 4 is in that particular branch. So we can apply that property. Sine inverse sine x equal x. That means this must be equal to pi by 4. Very clearly, pi by 4 belongs to the principal value branch of sine inverse x. Now the second term, cos inverse cos 3 pi by 4. Again, we have to see first whether 3 pi by 4 belongs to the principal value branch of cos inverse or not. If it is correct, if it is true, directly we can apply the property cos inverse cos x equal to x. So what is the principal value branch of cos inverse x? The range of cos inverse x is 0 to pi. 0 to pi. Okay. In between 0 and 180 in degrees, if I say. Okay. So very clearly 3 pi by 4 means 135 degree actually. So it is less than 180. So it is in the principal value branch of cos inverse x. So directly we can apply the property. There is no need of any simplification for that. So cos inverse of cos 3 pi by 4, that is same as 3 pi by 4. Okay, because 3 pi by 4 belongs to the principal value branch of cos inverse. Then the one more term is that is direct. You can write the value. No, tan inverse 1. Tan inverse 1, everybody knows the value is pi by 4. Okay. So substitute each and every value. Okay. First one is pi by 4. Second value is 3 pi by 4. And third value is pi by 4. Then add it. You see, last year, in some question papers, you can see this kind of question also. Draw the graph of sine inverse x. Yeah, draw the graph of cos inverse x, like that. So you must be thorough with the graph of every inverse trigonometric functions. Okay, you should have an idea of the rough sketch of the inverse trigonometric functions. So here is a question. Draw the graph of sine inverse x. Draw the graph of sine inverse x. X belongs to minus 1 by root 2 to plus 1 by root 2. Minus 1 by root 2 to plus 1 by root 2. So we have to remember the graph of sine inverse actually. Okay. Actually, I have shown you in the afternoon class the same graph. Sine inverse x, if I take the whole sine inverse x, that is a function from minus 1 plus 1. Domain is minus 1 to plus 1, closed interval. And the range, yeah, principal value branch is minus pi by 2 to plus pi by 2. Okay, if I take the complete sine inverse function. Okay, first I will draw the whole graph. You should have an idea of the graph actually. Okay, the shape of the sine inverse function, cos inverse function, etc. Okay, so this is the -1 to +1 is the domain, and minus pi by 2 to plus pi by 2 is the range of the sine inverse x function. So if I draw the whole graph, sine inverse -1 is, minus pi by 2. Image will be here. Sine inverse 0 is 0. And sine inverse 1 is pi by 2. And some other value also. Sine 30. Sine 30 is roughly somewhere here. Sorry. Sine inverse 1 by 2 actually. No? Sine inverse 1 by 2. This may be 1 by 2. Minus 1 by 2. So sine inverse 1 by 2 is what? 30. Pi by 6. Somewhere here. Roughly. Okay. So if you draw the graph, roughly if you sketch the graph, you will get in this shape. Okay. Roughly. The whole graph, -1 to +1. Sine inverse x graph. But we want the graph from -1 by √2 to +1 by √2 only. -1 by √2 to +1 by √2. Okay. So what is sine inverse of -1 by √2? The lower limit is here actually -1 by √2. -1 by √2 means what is sine inverse of -1 by √2? That is minus pi by 4. Okay. That means corresponding the range value will be minus pi by 4. Here. Okay. Roughly minus pi by 4. And the other end point is 1 by √2. Okay. So sine inverse 1 by √2 is pi by 4. Sine pi by 4 is 1 by √2. So that means we have to draw the graph up to here only. This is pi by 4. Okay. Pi by 4. So that means we have to consider the graph from this point, approximately from this point. This may be somewhere around 1 by √2. And here also around somewhere here. Okay. Roughly I'm just drawing. You can draw with a suitable correct scale, etc. So that is the only required graph we have to draw. Okay. So up to here around. Okay. And here also up to here only. So roughly, if you sketch, you will get a graph like this. Okay. If you want, I can show you the exact graph also. Just wait a minute. Okay. So this is the exact correct graph that is plotted using the software. Okay. GeoGebra. You can see here. Okay. Sine inverse x from -1 by √2 to +1 by √2. -1 by √2 to +1 by √2. √1 by √2 means around 0.7 something actually, nearly 0.7. Okay. So minus 0.7 nearly to plus 0.7. So you can see the graph is up to pi by 4 in the range, and lower value is minus pi by 4. Okay. So very clearly the range is here minus pi by 4 to plus pi by 4. Domain is -1 by √2 to +1 by √2. Okay. This we have to draw and practice actually. Cos inverse x graph also you have to practice, and sine inverse x graph also you have to practice. Okay. You remember cos inverse x graph? Just I will show you here itself. So this is a graph of the cos inverse x. If cos inverse x acts means the graph will be like this. Okay. The principal value branch is 0 to pi. 0 to pi. The graph is in between 0 to pi in the along the y-axis you can see. Okay. So please draw and practice this graph actually. Sometimes it may be asked in the exam. Last year it was there in some question paper. Okay. Now let us take another question. Find the domain of sine inverse x square minus 4. Find the domain of this function sine inverse of x square minus 4. Domain stands for what? Domain stands for the values what we can put for x. Na? Input means what are the possible values which can be put for x in this function sine inverse of x square minus 4. So how to do it? We know if the function is some sine inverse y, sine inverse y. So what are the possible values of y? What values can be put for y? Very clearly, that is -1 to +1. Okay, the domain of sine inverse x function is -1 to +1, the closed interval, -1 to +1. Remember, that's the basic idea here. Okay, so here it is something x square minus 4 is here. Sine inverse of x square minus 4 is there. That means that value must be in between -1 and +1. Okay, so that is the idea here. Okay, so therefore, since the principal domain of sine inverse function is -1 to +1, this x square minus 4 must be in between -1 and +1 in the closed interval, -1 to +1. Now from here, we have to do some algebra and find the suitable values for x. Okay, admissible values for x. So I need to get the value for x actually. So I will add 4 everywhere. Okay. So -1 plus 4 less than or equal to x square less than or equal to 1 plus 4. Adding 4 throughout each term. So -1 plus 4 means 3. So 3 less than or equal to x square less than or equal to 5. So this means that the value of x square must lies from 3 to 5. The value of x square, remember, x square must lies between 3 and 5. Now what about x? If x square is in between 3 and 5, x must be in between. Therefore, √3 less than or equal to x less than or equal to √5. Not only this interval, also, okay, other range is -√5 less than or equal to x less than or equal to -√3. For x, you will get two intervals actually, okay? X can be in between minus or √3 and √5 and also in between -√5 and -√3. Is it clear? For example, if I say another x square lies between 1 and 4, the value of x square belongs to the interval, closed interval 1 to 4. Then what can you say about x? Sometimes we may commit mistake. Okay, simply we say that x belongs to 1, 2. X belongs to 1, 2 is also correct, but not only this interval, there is one more interval. What is that? X also belongs to which interval? -2 to -1. Isn't it? For example, x is -1. X is -1. Then what is x square? X square is 1. So x square belongs to 1, 4. For x is -2. Then what is x square? X square is 4. Again belongs to 1, 4. Or x is in between -2 and -1. -1.5. X is -1.5. Then x square is 2.25. 2.25. So that belongs to again 1 to 4. No? So this idea, same idea. So we got the value for x. Therefore, x belongs to which interval? The closed interval root 3 to root 5, one interval, union, other interval is minus root 5 to minus root 3. So this is the domain of the given function. I think it is clear now. Let me see the chat box. Okay, let me see if any chat is there. So we need a PDF of question papers. PDF of question papers. I think the question papers, what I am discussing here, that may be, Okay, I will try. Okay, let us go to another question. I think some problems are very basic only, very fundamental only. So I am not going to discuss. Okay, let us take this question. Find the value of tan of cos inverse x. Tan of cos inverse x, and hence evaluate tan of cos inverse 8 by 17. So first you evaluate tan of cos inverse x. After that, we have to evaluate this particular value. So we need to calculate tan of cos inverse x. Tan of cos inverse x. So remember, we have to apply this property. Okay. If tan is there, we have to apply always tan of tan inverse x. Tan of tan inverse x equal to x, this property. The basic, very fundamental property. So, but here it is cos inverse x. Okay, inside the bracket, it is cos inverse x. So somehow we have to convert this cos inverse x in terms of tan inverse x. That is the only thing we have to do here. Okay. So let me take this cos inverse x. This cos inverse x, let us take it as some y. That means, which implies x is equal to cos y. X is equal to cos y. Okay. That means 1 by x is equal to sec y. 1 by x is equal to sec y. My target is somehow we have to reach the tan. Okay. So we have to reach tan actually. For that, if you know cos y, immediately we can find sec y. And if you know sec y, we can go for tan y also. Okay. Which implies 1 by x square. 1 by x square is equal to sec square y. Very simple, direct. Okay. Now, which implies 1 by x square minus 1 is equal to sec square y minus 1. 1 by x square y, 1 by x square minus 1 is equal to sec square y minus 1. What is sec square y minus 1? That is tan square y. So we got tan square y. Okay. And left side also we can simplify a little more. That is 1 minus x square all divided by x square. So we are almost reaching tan. Okay. Our target is to reach tan actually. So tan square y is arrived now. Now very easily we can move to tan y. So what is the next step? Which implies, take the root. Okay, root of 1 minus x square by x is equal to tan y. That means y is equal to, if y is equal to tan inverse of root of 1 minus x square by x. Okay. What is y? Y is our cos inverse x. Okay. Cos inverse x is taken as y. And that y now converted as tan inverse of root 1 minus x square by x. That means ultimately what we have done, this is cos inverse x. Okay. Y is nothing but cos inverse x. So cos inverse x is equal to tan inverse of root of 1 minus x square by x. Therefore, our required expression answer, cos of tan inverse x was the question. Okay, what is the given question? Write down. Therefore, cos of is it cos or tan? Let's see. Tan. Okay, tan of cos inverse x. Therefore, tan of cos inverse x, tan of cos inverse x is equal to, what happens? Tan of tan inverse. Tan of tan inverse something means the tan and tan inverse will operate each other. Okay, both are inverse of each other. So by the property, you will get root 1 minus x square by x. So this is the first part. Now using this expression, what we have obtained just now, using that expression, find the value of tan of cos inverse 8 by 17. Tan of cos inverse 8 by 17 means in place of x, you put 8 by 17. In place of x, put 8 by 17. Okay, that can be done by yourself. Therefore, our required answer, that is tan of cos inverse 8 by 17. That stands for root of 1 minus 8 by 17 whole square divided by 8 by 17. So you can simplify and find the answer. Okay. These are some 1 mark questions actually. Assertion reasoning, assertion reason type questions. Very simple. Everybody can give the answer. You know the options, okay? 4 options will be there actually. Okay. So assertion is the principal value of cot inverse root 3 is pi by 6. Principal value of cot inverse root 3 is pi by 6. Listen. And reason is domain of cot inverse x is r minus minus 1 comma 1. R minus minus 1 comma 1. So what is the correct option? There are 4 options actually, no? You know. A is true, R is true, and R is the correct explanation of A. Otherwise, A is true, R is false. Sorry, A is true, R is also true, but R is not the correct explanation of A, like that. So very clearly, the first statement is true. Na? Cot inverse root 3. Cot inverse root 3 is pi by 6. Na? Cot 30, I think. Cot 30 is root 3. Na? Is it correct or not? Yes, true. But the reason, domain of cot inverse x is r minus minus 1 comma plus 1. That is wrong. Okay. What is domain of cot inverse x? All real numbers. Okay. Then next statement. The maximum value of cos inverse x whole square is pi square. Maximum value of cos inverse x whole square is pi square. I think this also can be easily answered. Cos inverse x, the value is always lies between 0 and pi. Okay, cos inverse x, the value lies between 0 to pi. So cos inverse x square means definitely the maximum value will be pi square only. The maximum value of cos inverse x is pi. That means the maximum value of cos inverse x whole square is pi square. So that statement is true. What is the reason? Range of the principal value branch of cos inverse x is minus pi by 2 to plus pi by 2. That is false. Range of cos inverse x is 0 to pi. 0 to pi. All the remaining problems are very basic and simple problems. I am not going to discuss. Okay. Just I had collected these problems. That's why just you're showing, I am showing here. Okay. I think only this kind of questions are asking nowadays from this chapter actually, because all the properties are deleted. So only the basic properties are there. Sin inverse sin x equal x, cos inverse cos x equal x, tan inverse tan x. All these properties are only. So only the most of the problems are asking from the based on the principal value branches and the graph also. Okay. Please remember the graph of each inverse trigonometric functions. So now I am going to solve some problems from the differential equation chapter. Okay, differential equations. I think you must have studied this chapter. Okay, actually this chapter is included in the first term, for the first term. So you must have completed this chapter and everything you must have studied actually. Okay, in differential equation actually, we have to study three types of differential equation, the solution of three types of differential equations. Okay, first degree and first order. Only that is in our syllabus, first degree and first order. So there are three types of equations. First one is variable separable form. Directly you separate x and y and integrate. And the second type is homogeneous differential equation. Then we know the method. Either you put y equal vx, yeah, x equal vy, depend upon the equation. If it is dy by dx equal to form, then put y is equal to vx. And if it is dx by dy equal to form, then put x by y, yeah, x equal to vy, x by y equal to v, yeah, x equal to vy. And third one is linear equation, linear differential equation, that is dy by dx plus py equal to q form, dy by dx plus py equal to q form. Then we know how to integrate using integrating factor, etc. There is a formula for the solution. Okay, I'm not going to discuss all those things. Okay, just directly we will do some problems from this area. Now look at this question. Dy by dx plus 6 square x into y is equal to tan x 6 square x, given that y of 0 is equal to 0. So given differential equation is this one. Dy by dx plus 6 square x into y is equal to tan x into 6 square x. And one condition is also there. Y of 0 equal to 0 stands for when x equal to 0, y is equal to 0. Okay, otherwise that particular solution, a curve passes through the point 0, 0. That is to be used at the end to find the constant c. Okay. So this is our equation. So first thing is we have to identify this equation. This belongs to which type of equation? We have three type of differential equations, okay? So this equation, this particular equation belongs to which kind? Once you identify, then we can easily proceed with the corresponding method, okay? So very clearly this is of the form dy by dx plus py is equal to q, you know, where p is equal to 6 square x and where q is equal to tan x into 6 square x. P and Q are both completely functions in X. So this is a linear differential equation. This is a linear differential equation. Okay. Of the form dy by dx plus py is equal to q. Where p is equal to 6 square x. Okay, p is equal to 6 square x and q is equal to tan x into 6 square x. Tan x into 6 square x. So once you identified the type of the equation, we have to follow the method. So what is the method here? First we write the integrating factor. Okay, write the integrating factor. Integrating factor of this differential equation is what? E raised to integral p dx. This is the formula for the integrating factor. Okay, E raised to integral p dx. Now what is that? E raised to integral of 6 square x dx. P is 6 square x. And that is equal to e raised to integral of 6 square x is tan x. So e raised to tan x. So this is our integrating factor. Okay. Integrating factor is ready now. Now we have a ready-made solution. Okay. Just apply that solution. What is the solution? Therefore, the solution is what? Y into integrating factor. We have to by heart this formula. Okay, we have to by heart this solution. Y into integrating factor is equal to integral of q into integrating factor dx plus c. Actually, the constant will be put after the integration. Anyway, in that formula, we directly put c. Generally, we remember this formula as it is. Okay. So this is the solution. So just substitute the values which are obtained, okay, and also what is given, p and q, etc. Already we know. Okay, so put it. So y into e raised to tan x is equal to integral of q. What is q? Q is equal to tan x 6 square x. Tan x 6 square x. Tan x 6 square x into integrating factor e raised to tan x dx plus c. That is equal to, just to modify this as, just rewrite the terms. Okay, e raised to tan x into 6 square x dx plus c. Now the next step is to integrate. Okay, we should know the integration techniques for how to do this integral. If you look at the expression, you will come to know where to substitute like that. Okay, very clearly, tan x we have to substitute because derivative of tan x is the 6 square x dx. So if you put tan x as some u, yeah, some t, it reduces to e power t into t dt. Okay. So I think the remaining you can do if you know the basic integration. So put tan x equal to t. Okay. So this reduces to e raised to t into tan t into dt plus c. Okay, by putting tan x is equal to t. So it is not tan t only. Okay, tan x. So we have taken as t. So e raised to t into dt plus c. Then you know how to integrate it. Okay, integral of e raised to t into t means apply the integrating factor. Sorry, integration by parts. Okay, product rule. Yeah, integration by parts. So take the t as the first function. When algebraic function and exponential function comes, the algebraic function must be the first term, first function for integration by parts. Okay, so that's equal to first function into integral of second minus integral of derivative of first into integral of second. Integration by parts formula. Integration by parts. First function into integral of second minus integral of derivative of first into integral of second. That's equal to t e raised to t minus integral of e raised to t is e raised to t. Integration is over plus c. Again replace what is t? T is tan x. Okay. So tan x into e raised to tan x minus e raised to tan x plus c. And remember the left side from where we have started it, y e raised to tan x. Okay, this is y e raised to tan x. Therefore, y e raised to tan x equal to tan x into e raised to tan x plus, sorry, minus e raised to tan x plus c. If you want, we can divide by tan x. Almost everywhere tan x is there. So we can write y is equal to tan x minus 1, okay, dividing by e raised to tan x plus c by e raised to tan x. Yeah, c into e raised to minus tan x. We can write like that. So this is the general solution, okay? This is the general solution of the given differential equation. General solution means that contains always an arbitrary constant. So there will be an arbitrary constant, okay? Now also in the given problem, in the beginning, it is given that y of 0 is equal to 0. Y of 0 is equal to 0 means when x equal to 0, y is equal to 0. That condition is only for to find the value of c, isn't it? So when x equal to 0, y equal to 0, that is given in the question. So apply the condition here and get the value of c. That will give the particular solution, okay? So given that y of 0 equal to 0, that is x equal to 0, y equal to 0. When x equal to 0, y equal to 0. So put it here. Let me take it as equation 1. Okay, the general solution. Therefore, the general solution gives 0 is equal to tan 0 is 0 minus 1 plus c into e raised to 0. Tan 0 is 0. That means what you will get? 0 is equal to minus 1 plus c into e raised to 0 is 1. So minus 1 plus c equal to 0. So that will give the value of c as 1, isn't it? So which implies c is equal to 1. So the particular solution is obtained by putting c equal 1 in the equation 1. Okay, that means the corresponding particular solution is y is equal to tan x minus 1 plus e raised to minus tan x. Okay. Okay, some comments are also there. Now only I could see. And some question is there. So we have one doubt using integration find the area of the triangle ABC whose vertices are -1, 1, 0, 5 and 3, 2. I think I will see. If time is there, I will see. Okay. The vertices are given -1, 1, 0, 5, 3, 2. Okay. Okay, let us take another question. This one. Find the general solution of the differential equation dy by dx minus 2y by x equal to sine of 1 by x. Dy by dx minus 2y by x equal to sine of 1 by x. So I think it is very clear that it is a linear differential equation again. Okay, dy by dx plus py is equal to q form. Dy by dx plus py is equal to q form. So what is p? What is p? P is equal to minus 2 by x. Okay, the coefficient of y is minus 2 by y. Sorry, minus 2 by x. And what is q? Q is equal to sine of 1 by x. Sine of 1 by x. So immediately write the integrating factor. What is the integrating factor? Therefore, integrating factor is equal to e raised to integral p dx. E raised to integral minus 2 by x dx. E raised to integral minus 2 by x dx. And that is equal to e raised to minus 2 is a constant, minus 2 into integral of 1 by x dx means log x. Okay. And that can be further written as e raised to log of x raised to minus 2. Log of x raised to minus 2. And we know that e raised to log means e and log are inverses of each other. So you'll get x raised to minus 2. X raised to minus 2 means 1 by x square. Okay. I think it is clear. So this is our integrating factor. Okay. Once you know the integrating factor, just write the solution. Therefore, the solution is what? Y into integrating factor. Integrating factor means 1 by x square. Y into integrating factor is equal to integral of q into what is q? That is sine of 1 by x. Sine of 1 by x. Q into sine of 1 by x into integrating factor, that is 1 by x square dx plus c. Okay. Now we have to integrate. The integration is very simple. What is the method? You put 1 by x equal to t. 1 by x equal to t. Then the derivative of 1 by x is minus 1 by x square. So 1 by x square you can see here. So 1 by x square dx becomes minus dt. Minus dt. That means this reduces to sine t into minus dt. Integral of sine t is very fundamental integral. You know, everybody knows. So please write down and complete it. Okay. Let's look at this question. Find the particular solution of the differential equation dy by dx equal to sin x plus y plus sin x minus y, given that x equal to pi by 4 when y equal to 0. This condition we have to apply at the end only. Okay, this condition we have to apply at last. Don't think about in the from the beginning. There is no need of taking that now. So first thing we have to solve it. How to solve this differential equation? That is the major part. So dy by dx equal to sin of x plus y, sin of x plus y plus sin of x minus y. Then you tell me, which type of equation is this? Which type of differential equation is this one? There are three types of differential equations. So this belongs to which category? Yeah, how to do this one? If anybody is having any idea, immediately put in the chat box. Okay, immediately. Homogeneous. Variable separable. Substitution and variable separable. Okay. Good. Some comments are coming. Substitution and variable separable. So where to substitute actually? Where we will substitute. Okay, anyway, it is ultimately, finally, you will get variable separable form. Okay. There is no need of any substitution, I think. I don't know whether maybe some other technique may be there. But directly, you can apply a trigonometric identity. This is a very fundamental trigonometric identity what we have studied in 11th class. Okay, sin x plus y plus sin x minus y. Sin x plus y plus sin x minus y. What is sin x plus y? Sin x cos y plus cos x sin y. What is sin x minus y? Sin x cos y minus cos x sin y. If you remember those identities, also we will get it. Otherwise, directly also we have studied as it is. Sin x plus y plus sin x minus y is equal to 2 sin x cos y. Remember? Sin a plus b plus sin a minus b equal to 2 sin a cos b. So if you remember that identity, immediately without any substitution or anything, you can write it. Okay. So this is nothing but 2 sin x into cos y. Direct identity actually. Those who remember this identity, immediately they can write like this. 2 sin x cos y. Now it is variable separable. Very clearly, we can separate. Okay. You take dx in the other side and the cos y in the left side. Okay. Therefore, the remaining thing you can do. Anybody can do it. Only the thing is, you must get the idea. Okay. You must get the method, which type of equation, what can be done. That's the important thing. Once you know it, once you know this idea, everything is very simple. So dy by cos y is equal to 2 sin x into dx. Okay, we take dx other along with the sin x and cos y bring here. I think the remaining portion you can do. There is no need to give the remaining portion. Okay, 1 by cos y means, sorry, 1 by cos y means sec y. Okay, integral of sec y we know. Integral of sec y we know the standard formula, and again 2 sin x integral we know. So integrate it, and after that finally you find the value of c by putting x equal pi by 4 and y equal to 0. So it is so simple. Okay, if you know this identity, it is very simple. There is no need of any substitution. Direct identity we have to apply. Okay. Okay, now look at this question. Find the general solution of the differential equation d by dx of xy square equal to 2y into 1 plus x square. D by dx of xy square equal to 2y into 1 plus x square. So it is given here d by dx of xy square. Okay, so we have to differentiate it. Okay, and make a into the one of our standard differential equation form. So what is d by dx of y square? Product rule. Product rule. Okay, x into derivative of y square with respect to x. D by dx of y square means 2y dy by dx. 2y into dy by dx plus product rule plus y square into derivative of x means 1. So y square, that is equal to same 2y into 1 plus x square. Correct? Then what we have to do? So 2xy dy by dx, 2xy dy by dx is equal to 2y into 1 plus x square minus y square. Normal simplification only. Okay, minus y square. Then divided by 2xy. So therefore dy by dx equal to 2y into 1 plus x square minus y square divided by 2xy. Okay, 2y into 1 plus x square minus y square divided by 2xy. Then what to do? Divided by 2xy, each term, separate it. So first term becomes 2y cancel. So 1 plus x square divided by x. 1 plus x square divided by x minus y square by 2xy. Y square by 2xy means y will cancel. You will get y upon 2x minus y by 2x. Normal simplification. Okay. So sometimes the differential equation may not be given so directly. Here is an example. This is an example actually. So we have to do some simplification and make it in one of the form. Now again, almost we are reaching. Now you can say, I think, which type of differential equation is this one? we can bring this minus y by 2x here, left side. Then again, it will be more clear. Okay, so dy by dx plus y by 2x, that is equal to 1 plus x square divided by x. 1 plus x square divided by x. Now I think it is clear. Now the picture is clear, means which type of differential equation is this one. Okay. So this is a linear differential equation. Okay. dy by dx plus py. P is 1 by 2x equal to q. Q is 1 plus x square by x. So integrate by means the method using that method of linear equation. Okay, so P is what? P is 1 by 2x and Q is equal to 1 plus x square by x. So integrating factor is equal to integral of, sorry, e raised to integral p dx 1 by 2x dx. E raised to integral 1 by 2x dx, that is e raised to 1 by 2 is a constant, take it outside, then 1 by x dx means log x, and that's equal to e raised to log x raised to 1 by 2, log of x raised to 1 by 2, and that's equal to x raised to 1 by 2. Yeah, root x, we can say. So this is the integrating factor. Okay. Normal procedure. Integral of 1 by 2x dx means 1 by 2 into log x. That is log of x raised to 1 by 2. Then okay, let me check the chat box. Okay, in between. Okay, so integrating factor is root x. Integrating factor is root x. So the next step is, you know how to write, get the solution. Write the solution formula. What is the formula? Solution is, therefore solution is y into integrating factor is equal to integral of q. What is q? Q is equal to 1 by 1 plus x square by x. 1 plus x square by x. Q into integrating factor means root x dx plus c. Okay. Now I think you will be able to integrate it. Okay. How to integrate it? This root x can be cancelled in the denominator, isn't it? Root x will cancel here. So root x will come here. Then divide by, okay, 1 by root x plus x square by root x. X square by root x means x raised to 3 by 2, isn't it? Very easily we can integrate this one. Very easily we can integrate it. Okay. So another question. And just I am choosing some particular examples only, okay? So the question is x dy by dx equal to y into log y minus log x plus 1. X dy by dx equal to y into log y minus log x plus 1. So this can be modified as dy by dx equal to divided by x, that is y by x into log y minus log x can be written as using the property of logarithm, that is log of y by x plus 1. So dy by dx equal to y by x into log of y by x plus 1. So which kind of equation is this one? This is homogeneous, okay? Homogeneous. Whenever we say some function totally in terms of y by x, yeah, x by y, okay? If a function is expressed some function of the form y by x, yeah, x by y, then definitely it will be homogeneous, okay? So homogeneous means we know the method, put y by x equal v. The method is y by x equal to v. Yeah, y is equal to vx. Y is equal to vx. Therefore, y is equal to vx means definitely we know always dy by dx equal to v plus x into dv by dx. Okay, this is the value for dy by dx when y is equal to vx. So substitute in our given original differential equation. So the given equation becomes differential equation becomes dy by dx in place of dy by dx, that is v plus x into dv by dx equal to y by x. Y by x stands for v into log v plus 1, log v plus 1. That is v plus x dv by dx equal to v log v plus v. Bracket, remove the bracket, so that on both sides we can see v. So v and v can be cancelled. Okay, v and v can be cancelled. Now what is remaining? X dv by dx equal to v log v. So that can be easily separated. No? Now it is in the variable separable form actually. Variable separable form. What to do? Take all the v here and dx by x on the other side. That means dv divided by v into log v. dv divided by v into log v, that is equal to dx by x. dx by x. So easily integrating, you will get the solution. Okay. So right side is direct integral. Left side is not that much direct, but you know, if you put log v as some t, so 1 by v dv will become dt. Okay. Put log v as t, so 1 by v dv becomes dt. So it becomes 1 by t dt form. 1 by t dt. Again, that is a standard integral. So remaining you can easily complete by yourself. Okay. Now look at this question. Y dx. So show that the equation, differential equation y dx plus x log of y by x dy minus 2x dy equal to 0 is homogeneous, and then solve it. Is homogeneous, and then solve it. So we have to rewrite this equation actually first. Okay, the given equation we have to rewrite either dy by dx equal form or dx by dy equal to form. So this can be written as y dx is equal to, you see, the remaining two terms are involving dy. Okay, in both the terms there are dy. So take that dy terms on the other side. That is equal to 2x dy minus x log y by x log y by x into dy. Sorry, into dy. That is y dx equal to 2x minus x log y by x log y by x, everything into dy. So how to prove it homogeneous? Homogeneous means either it may be totally in terms of y by x or totally in terms of x by y. Okay, we have to convert as a function in terms of y by x or in terms of x by y. So here you can see a log of y by x is here. But if I divide by x, you will get, so you divide by y. If I divide by y, you will get x by y here. Okay, x by y will be here, but it is here log y by x. So what to do? Okay, let us take the dy here. So you will get dx divided by dy, dx by dy equal to, bring the y, divided by y, so you will get 2x by y, 2x by y minus x by y into log y by x. Okay, dividing by y and taking dy in the left side, dividing by dy to the left side. Now, what can you observe? Is it a function of throughout y by x or x by y? No. First two terms you can see x by y, but in log you can see y by x. So very simply we can convert log of y by x as log of x by y, because property of logarithm, log y by x is same as minus log x by y, isn't it? So let us rewrite in that way, so that you will get 2x by y minus x by y, minus become plus. Okay, if I reverse the term, so plus log x by y. Log of y by x is written as log of x by y. Then sign will reverse, means the sign will be negative. So minus into minus is plus. Now you can see it is a function of x by y, and the left side is dx by dy. So dx by dy is equal to some function. If you want, x by y can be taken outside also. Okay, x by y is common. So x by y into 2 plus log x by y. Isn't it? Now you know the method. Put x by y equal to v. Okay, homogeneous, which is, it is a function in x, function in x by y, f of something, f of x by y form. So that means it is a function in, it is a homogeneous function. So homogeneous function means here we have to put x by y is equal to v, and as usual differentiate and find the solution. Okay, I think now everybody can complete it. Okay, children. Now let me address one of the query, a doubt received in the chat box. After that, we will wind up our session. Okay. Somebody has some comment is the so sir taught efficiently in well executed way. Besides, sir, you have done excellent job for okay something some appreciation. JNV Puducherry. Okay, thank you, sir. I don't know how much justification I have done within this short period of time. Whatever possible, uh, I have done here, and I also got this opportunity. I came to know about this program just 2 days before the starting of this program. Okay, so I also could not that much prepare and anyway whatever I have the material whatever material I have I came here and delivered. Okay, anyway thank you for your compliment. So let me address one of the doubts what I have observed in this chat box. Okay, after that I will finish. Okay, the problem is find the area of the triangle whose vertices are -1 1 0 5 and 3 2 -1 1 0 5 and 3 2. Okay, let me plot the 3 points, given points, -1 1 0 5 and 3 2. -1 1 -1 1 is here. -1 1 first point. The next point is 0 5. Isn't it? 0 5 and 3 2. 0 5 and 3 2. Okay, wait a minute. Okay, -1 1 0 5 and 3 2. So if you join these, okay, you will get a triangle actually. So the question is to find the area of this triangle. So it is a question from the application of integral chapter actually. Okay, application of integral. I will just tell you the method. Okay, I will not do everything here. So what we have to do here, so we need to find the area bounded by these 3 line segments, means the area of this triangle actually, area of this triangle. Okay, so how to get this triangle area means, first we find the area of the whole trapezium. The whole figure, if you take it is a trapezium, you know, you can put some name also. Okay, in my figure here, D, A, B, C, E, it is a trapezium. So from that trapezium, if we subtract the uh, area under AC, that is also actually a trapezium. Area below the line segment AC, that is also trapezium. Okay, but we have to use integration only, not the basic area of basic formula of trapezium. For that, what to do actually? What we have to do is, first we integrate the line segment AB. Okay, this one. Let us say it is some y1, the equation of that curve, the y let us take it as y1, okay? And let me take this as some y2, and third one, take it as some y3, okay? But why we have to find out actually, okay? It is the equation is not given. Equation of AB is not given. Equation of AC is not given. Equation of BC is also not given. So that we have to find out, okay? How to get the equation? I think it's 11th class coordinate geometry problem. How to get the equation of AB? You know, eh? The point is -1, 1 A, and the second end point is 0, 5. So line segment passing through A and B means the equation of that line will be how to get the line. We have a formula, na? Equation of AB. How to get it? 2-point form. Y minus y1 divided by y2 minus y1 is equal to x minus x1 divided by x2 minus x1. This is the formula. This is the formula to write the equation of a line passing through the 2 points. Okay. So using that, we will find the equation of AB. First point you can take as x1 y1. Second one of the point you can take x1 y1, other as x2 y2. Then you will get the equation as y minus 1. Okay, y minus y1 divided by y2 minus y1. 5 minus 1, that is 4, equal to x minus x1, that is x minus minus 1, x plus 1, divided by x2 minus x1, that is 0 minus minus 1, that is 1. So this is the equation of the first line segment AB. Okay. For integration, we need the y of this equation actually, y part. So that also can be easily obtained from here. So y is equal to 4 into x plus 1. 4 into x plus 1 plus 1. Y minus 1 is 4 into x plus 1. So y is equal to 4 times x plus 1 plus 1. Okay. That is 4x plus 5 actually. If some error may be there, you can correct it. Okay. So y1, the y of the first line segment AB, that is equal to 4x plus 5 actually. 4x plus 5. Similarly, you find BC, equation of BC and equation of AC also. Okay. Once you know the equation, we can integrate. If you integrate minus 1 to 0, okay, minus 1 to 0, you will get to this area. Area under this line segment, isn't it? Okay. That is minus 1 to 0. Integral from minus 1 to 0, y1. Y1 means the y of that particular line segment, the equation of that line. That is 4x plus 5. I think so. It is, I think it is correct. Okay. It may be, some error may be there. You can correct it. Okay. 4x plus 5 dx. Similarly, find equation of BC. Equation of BC. Some y2 you will get. Take it as y2. Again, integrate that one. Okay, from 0 to 3 actually. Lower limit is 0, upper limit is 3. So you will get this area. This is portion. Okay, that means the whole area of the trapezium. Okay, so add the first two in area, then subtract area under AC. Area under AC, let us take it as y3. For that, we have to find the equation of AC using the same formula. Okay. So first you find the equation of AB, equation of BC, equation of AC using the same formula. Point may vary. Okay, then the points will vary. That's all. So same formula, you will get 3 equations, AB, BC, and AC. Then integrate each part. Area under AB, then area under BC, then area under AC. So required area means what? Area under AB plus area under BC minus area under AC. Okay. So this is the method. So I think it is time to wind up our class. Actually, it's almost 8 only. So once again, thanks to all the viewers, all the children of NVS region, NVS Hyderabad region. And also I take this opportunity to thank the Deputy Commissioner of NVS RO Hyderabad and other officers and the venue principal, Sri Parthiban sir, and the coordinators are Sir Dinesh Kurupu sir, Vice Principal of JNV Chamaraj Nagar. Okay, let's hope from this session, from these classes, I think some useful things, some students may be helpful from this class, I think so. So hopefully let us meet again in future somewhere. Okay, so thanks to all of you. Okay, so we'll wind up here. If anybody want to say anything, you can say, or you can put in the chat box.
Thank you, sir.
Hello, bro. We are from JNV'S Chikranapur.
Okay, thanks to all of you. We'll stop here. Okay, thanks to all of you.